The entire universe will be aware of this one explosion.
Let's see what's really behind the royal smiles. Just minutes ago, Betelgeuse's huge explosion began, and everything is changing fast. This giant star, which we've watched in the sky for so long, has finally blown off a huge part of itself, sending powerful energy into space. 7 minutes ago, it threw a massive chunk of its surface, shaking so hard that scientists are stunned. Could this be the start of Betelgeuse's final collapse? Tune in as we break down exactly what's happening and what this massive explosion could mean next. A rare look into its final days. Imagine standing at the edge of the world, looking out as the sun starts to rise, filling half the sky with light. NASA has just revealed something never seen before. A star called Betelgeuse erupted, throwing a massive piece of its surface into space. This event, called a surface mass ejection, launched an amount of material 400 billion times more than what the sun releases during a solar flare. Scientists are amazed by this rare look into a star's life cycle, something they never expected to witness up close. As everyone reeled from Betelgeuse's explosion, a new message from space hinted that other stars were also acting weird. Betelgeuse is not just any star. It's a huge red star in the Orion constellation, known for its bright reddish-orange glow, easily spotted in the night sky. The star seems alive, expanding and shrinking every 400 days like it's breathing. But this recent eruption, where the star shed a big part of itself, has left scientists speechless. If Betelgeuse took the sun's place in our solar system, it would swallow Mercury, Venus, Earth, and Mars, and almost reach Jupiter. It shines with the power of 126,000 suns, but is cooler than our sun, which gives it its red color. Even though Betelgeuse is only about 10 million years old, which is young in the universe, it's nearing the end of its life. Big stars like Betelgeuse burn through their fuel quickly compared to smaller stars like our sun, which has billions of years left. When stars like Betelgeuse run out of fuel, they go through huge changes, eventually collapsing and exploding into a supernova. A supernova is one of the most powerful events in the universe. It's an explosion so bright it can outshine entire galaxies for a short time. Scientists have known for a while that Betelgeuse will explode one day, but no one knows when. It could be tomorrow, or it could take 100,000 years. When it does happen, it will light up the sky, shining brighter than the full moon for weeks. But here's where it gets even more interesting. In 2019, Betelgeuse dimmed a lot, and many thought this might be the start of the supernova. However, scientists now think the dimming was caused by dust formed when the star threw off a huge part of its outer layers. This dust cloud blocked the star's light from reaching Earth. Since then, Betelgeuse has brightened again, but its usual pulsing pattern has been thrown off. The star is trying to recover from that massive eruption, but that's not the scariest part. Stars like Betelgeuse are important for the universe because when they explode, they spread elements like carbon and oxygen, which are essential for life. These explosions also help form new stars and planets, continuing the cycle of life and death in the universe. The recent observations of Betelgeuse give astronomers a rare chance to study a star in its final stages. This outburst might be a sign that the star is getting closer to its final explosion, but no one knows for sure when that will happen. Meanwhile, NASA's James Webb Space Telescope is keeping a close eye on Betelgeuse, tracking the material it threw into space. This new technology lets astronomers see the star in greater detail than ever before, offering fresh insights into what's happening inside this dying giant. Although Betelgeuse's supernova won't harm Earth, it's too far away. It will still be a sight to remember. The explosion could be as bright as a full moon, visible even during the day, and it could stay bright for weeks. Until then, Betelgeuse keeps going, a massive star nearing the end of its life, putting on a cosmic show for everyone on Earth to see. Over time, galaxies have grown from simple beginnings into a vast universe filled with stars. The James Webb Space Telescope has shown us something surprising. Galaxies were not as rare in the early universe as we once thought. Instead, the universe seemed full of them. This discovery changes much of what scientists believed about how the universe has developed. The small and advanced galaxies that the JWST found could completely change our understanding of the universe's history and even the basics of cosmology. Think about looking into the farthest parts of space through the most powerful telescope ever made. You might expect to see faint, tiny galaxies scattered far away. But surprisingly, these distant galaxies are not small at all. They're almost the same size as galaxies close to us. This goes against what we thought about how light behaves in space. Normally, as galaxies move farther away, their light stretches, making them look smaller, a process called redshift. But JWST shows distant galaxies appearing much larger than expected, which raises big questions about how we understand the universe. In our current view, the universe has been expanding since the Big Bang, which caused galaxies to spread apart. As light travels through this expanding space, it stretches, making far-off galaxies appear smaller. But JWST's pictures challenge that idea. Galaxies that should look faint and tiny are instead large and bright. This forces scientists to rethink how the universe is growing. If galaxies aren't getting smaller as they move away, it might mean our ideas about cosmic expansion need a major update. The JWST also found galaxies with very high redshift levels, meaning they're moving away from us faster than we ever imagined. Normally, this would support the idea that the universe is expanding more quickly. However, these galaxies don't behave the way we thought they should. Instead of appearing dim and small, they look big and bright, much more developed than we expect for their distance. This discovery puts our whole idea of the expanding universe at risk. Next, we explore surprising truths from the farthest reaches of space. JWST alien findings. One of the most important parts of galaxy formation is the chaos expected in the early universe. Scientists believed that galaxies would show signs of collisions, warped shapes and twisted arms from crashing into each other. But the JWST shows galaxies that look smooth and orderly, without any signs of these violent encounters. These galaxies, instead of being chaotic, seem calm and structured, much like the galaxies closer to us. This unexpected smoothness suggests that either our ideas about galaxy formation are missing something, or the early universe was much less chaotic than we thought. Here's where it gets even more surprising: the age of the stars in these galaxies. Some of these stars appear older than the universe itself, according to current models. This suggests they existed before the Big Bang, a completely mind-blowing idea. Stars this old, in galaxies that formed just a few 100 million years after the universe began, shouldn't exist. If this finding holds up, it could force scientists to rethink the timeline of the universe and the physics that explain how it all began. The JWST's discoveries are affecting more than just our understanding of galaxies. They're challenging the Big Bang theory itself. According to this theory, the universe started from a tiny, hot point almost 14 billion years ago, and everything we see has been expanding ever since. But the existence of galaxies that are too mature and large for this timeline makes us question how these galaxies could have formed. If they existed so early in the universe's history, how does that fit with the idea of a single explosive beginning? The more we explore with the JWST, the more mysteries we find. Every new image and discovery reveals a universe that's more complex than we ever imagined. Scientists are now rethinking the very laws that describe how galaxies form, how the universe expands, and even how old the universe might be. Could the universe be more organized than we thought? Is it expanding differently? Or could it even be older than we believe? The answers to these questions might change everything we know about reality. These discoveries also lead to deeper, more philosophical questions. If galaxies and stars existed before we thought possible, and if the universe is growing in ways we can't fully explain, what does this say about existence itself? Some scientists are starting to wonder if time is even real. Could time just be something we experience, but not something that really exists in the structure of the universe? Maybe the past, present, and future all exist at once, just waiting to be discovered in the fabric of space. The JWST isn't just showing us stars and galaxies. It's breaking down old ideas and making us rethink what we know about the universe. Each new discovery brings us closer to understanding the cosmos in a deeper way, possibly even challenging our most basic beliefs about time, space, and the nature of reality itself. The challenge of understanding how matter is spread out across the universe has become a major hurdle in figuring out its structure and history. When scientists study the universe close to us, they see how matter clumps together, partly thanks to weak gravitational lensing. But when they look much further back in time, at the light left over from the Big Bang, the cosmic microwave background, CMB, it paints a different picture, one of smoother matter distribution. This difference creates a puzzle, showing that we don't fully understand how the universe evolved from its early, smooth state to the more clumped one we see today. These conflicting findings are making scientists question whether we truly understand the forces shaping the universe. Some believe we might need new theories to explain how matter works on both small and large scales. These new ideas could change the way we view the universe entirely, and solving this puzzle could be a huge breakthrough in cosmology, helping us learn more about how the cosmos has developed over time. At the heart of this investigation is the Flamingo Project, a large-scale effort run by Durham University. Using one of the world's most powerful supercomputers, the project aims to simulate the entire universe, including both the matter we can see and the dark matter that influences its structure. The team dedicated over 50 million hours of computing time to create these detailed simulations, which range from swirling galaxies to enormous black holes. But even with all this computing power, the Flamingo Project still hasn't fully solved the problem of the different matter distributions. This shows just how tough it is to match our theoretical models with the real data we gather from observing the universe. It also reminds us of the limits of even our most advanced tools when faced with the complexity of cosmic forces. But this isn't the most frustrating part. The real challenge in cosmology, including understanding the universe's expansion and its matter distribution, isn't just a technical problem. It's driving scientists to innovate, creating new tools, techniques, and collaborations. Physicists, astronomers, and computer experts are all coming together to improve our understanding of how the universe works. The JWST has already made some exciting discoveries, such as spotting an exoplanet called GJ 163c, located about 49 light-years away in the constellation Dorado. This planet sits in its star's habitable zone, where conditions might allow liquid water to exist, making it a prime candidate in the search for life beyond Earth. The instruments on the JWST are crucial in studying planets like GJ 163c. Its near-infrared camera, NIRCam, takes incredibly clear images of these faraway worlds, while its mid-infrared instrument, MIRI, helps analyze their temperatures. By studying the light that passes through a planet's atmosphere when it crosses in front of its star, the telescope can detect chemical compounds that might hint at the possibility of life. Now, let's look closer at the search for life on other planets. Big step in finding life beyond Earth. These discoveries open a new chapter in our exploration of the universe. As we keep searching for planets like Earth and uncovering the mysteries of space, we get closer to answering the big question: could life exist elsewhere? And what would that mean for us? Scientists are now using advanced technology to explore the possibility of liquid water on distant planets, which is essential for life as we know it. These high-tech tools capture incredibly detailed images and data, helping researchers understand the landscapes and weather of these far-off worlds. One big goal is to measure the planet's mass to figure out how strong its gravity is and what kind of atmosphere might exist there. Each discovery brings us one step closer to answering a major question. Could GJ163c be a future home for humans? Or maybe it already hosts some form of life? In this process, we're not just looking for answers, but aiming to understand what's beyond our solar system. The discovery of GJ163c sparks curiosity, not just among scientists, but also the public. Teachers can use this new information in classrooms, showing students how our knowledge of the universe is always growing. GJ163c, a planet that might support life, brings scientific theories into real-world research. And it's not just for experts. Media coverage and popular science discussions make these topics more engaging and accessible. People get more involved in astronomy, with interactive activities like talks, workshops, and even projects where non-scientists can help with research. This excitement could lead to more support and funding for space exploration, ensuring that the study of planets outside our solar system continues to grow. But this isn't the most surprising part. The data from GJ163c is pushing scientists to rethink how planets form and support life. New research shows it's not just about how far a planet is from its star. Scientists are now looking at things like what gases are in the atmosphere, how stable the planet's orbit is, and if it has a strong magnetic field. They are studying GJ163c's special features, like its volcanic activity and atmospheric composition, to see if life could exist in conditions very different from Earth's. By looking at planets like this, scientists are learning more about planets in other star systems and where life might exist throughout the galaxy. GJ163c could lead to the discovery of new types of planets that might support life, changing how we think about finding life beyond Earth. Exploring Neptune and its large moon, Triton has uncovered a world of powerful storms, icy winds, and deep mysteries. In 1989, Voyager 2 got close enough to provide a lot of new information about Neptune's atmosphere, magnetic field, and moons. Scientists found huge, long-lasting storms, like the Great Dark Spot, which showed that Neptune is far from calm. Winds on Neptune can blow up to 1,600 miles per hour, the fastest in the solar system. This data has changed how we think about giant planets and raised new questions about how such intense weather can happen so far from the sun. But even more curious is Triton, Neptune's biggest moon. Unlike any other moon in the solar system, Triton orbits Neptune in the opposite direction, which suggests it was captured by Neptune's gravity later in its life. Triton is also geologically active, with ice volcanoes that release nitrogen gas, hinting at a possible ocean beneath its frozen surface. Triton's unusual orbit and activity make it stand out and offer clues about how life might survive in extreme environments. As technology improves, the tools we use to study these distant worlds become even more advanced. The Hubble Space Telescope and the James Webb Space Telescope allow scientists to observe Neptune and Triton with more detail than ever. The James Webb Space Telescope, for example, can see through Neptune's thick atmosphere, giving new insights into its weather and heat activity. It's also providing fresh data about Triton's icy surface, helping to solve the mysteries of these distant celestial bodies. Looking forward, NASA's Neptune Odyssey mission, planned for the 2030s, promises to deepen our understanding of Neptune and Triton. This mission won't just do a quick flyby. It aims to study the planet and moon in detail, focusing on their atmospheres, geology, and the possibility of water beneath the surface. The findings from this mission could revolutionize our knowledge of how planets and moons in other star systems develop and whether they can support life. Could life in distant galaxies survive a supernova, or could it wipe them out? Let me know your thoughts. And don't forget to like and subscribe for more discussions.